So before we get into specific examples, let's talk about all these letters that I have now added to our exponential function. We started with just b to the x. Now we've got an a in front, a times b to the x. We're subtracting a number from x, and we're adding a number to the end of it. So let's talk about what all these things do, and then we'll look at some specific examples. H is the horizontal shift. That's easy to remember, right? H is horizontal. Now, here's the deal with horizontal. It's always the opposite of what you would expect it to be. So if it's plus, you expect plus to go to the right, but plus actually shifts you to the left. And a minus is going to shift you to the right. Okay, so it's backwards. I know it's a little confusing. It's just, the reality is you can look at it. Okay, you can look at the graph. So it's really not that bad, but I just want to establish it with this first. Okay, K is the vertical shift. I don't really have an easy way of helping you remember that other than H is horizontal, so K is the other one. Okay, but the good thing about vertical shifts is that's what we expect them to be. So a positive is going to go up, and a negative is going to shift us down. Okay, now, if A, that number in front, is negative, the function is reflected, that means you flip it, across the y-axis. Not the y-axis, sorry, the x-axis. I was thinking about the y values, but it's across the x-axis. My bad. Across the x-axis. Okay, it's reflected across the x-axis, so it flips it up and down, but that's across the x-axis. If the absolute value of A is greater than 1, that represents a vertical stretch. And if it's between 0 and 1, that represents a vertical shrink. Okay, so let's look at some examples. They say the directions are A, identify the parent function. So that's saying zoom in on what the original exponential part is. And then B is describe the transformations. So you're looking for where, excuse me, bless you. What has just the exponent of x? So the parent function here is 3 to the x. So I circled it so that I can kind of look at, well, what else are we doing to this? So in addition to the 3 to the x, which we just graphed a few minutes ago, it's adding 5. Okay, so it's adding 5. That's a k. Okay, that's k. K is a vertical shift, and it's adding, so it's up 5 units. So I kind of know what this looks like because we just graphed 3 to the x a minute ago, and since it shifted up 5 units, normally I started at 0, 1. So if I go up 5 units, 2, 3, 4, 5, 6, I'm going to be up at 0, 6. And then I can fill in my function from there. And I kind of ran out of room, but you know what the exponential functions look like. It doesn't ask us to do this, but let's talk about a few things. What change? Okay, what changes? The y-intercept changes from 0, 1 to, if we go up 5 units, that goes to 0, 6. The range, if it was y is greater than 0, if we go up 5 units, now it's y is greater than 5. And the asymptote, if it was y equals 0, then we go up 5 units, so that's going to be y equals 5. The domain doesn't change because we haven't done anything to the x values. What else did we talk about? The end behavior, okay, the end behavior. The right side still goes to infinity, but the left side, as our x values approach negative infinity, our y values aren't approaching 0, they are approaching 5, okay, because we went up 5 units. So if they were approaching 0, now they're approaching 5. Okay, so we vertically shifted up 5 units. So anything that had to do with the y value in those characteristics from before have been increased by 5. Okay, let's look at number 2. Okay, let's look at number 2. What is our parent function? It's 1/4 to the x is the parent function. Okay, you focus on just what's the base with the exponent of x. So let's talk about the transformations here. We've got 2. We've got a number in front, and we've got a number added, or in this case actually subtracted from the x. So let's deal with the number in front. That 2, it's not negative, okay? And it's greater than 1, so it is a vertical stretch by a factor of 2. So all of our y values are increased by 2. All of the original y values. Okay? And that -1, it's a horizontal shift because it's with the x, so that's horizontal. Okay? And it's -1, so that's the opposite of what we would expect. That's actually right 1 unit. Okay, it's shifted right 1 unit. Now, I didn't compare the graphs on the first one, but we've got several things going on here. So let's look at this, okay? And let me show you what you can do if they were asking you these questions. You graph the parent function, 1/4 to the x. Okay, graph the parent function, 1/4 to the x. And then you type in the transformation. 2 times 1/4. Now, they don't put parentheses here, but you need parentheses around the entire exponent. Okay, so notice how I've got parentheses. I still need them around the 1/4, but I also need them around the x minus 1. Okay, parentheses around the x minus 1. So, let's see here. Let's make this one darker so I can tell the difference. Okay. So here's the original parent function, and here comes the transformation. Okay, here comes the transformation. So it's kind of hard in this window to see that vertical stretch, but it is steeper. Okay, it is steeper than the other one, and it is shifted right 1 unit. Okay, it is shifted right 1 unit. It's a little bit harder to see. On this one, when you shift and stretch, it's harder to see, but we can you can definitely see that it's further to the right? Okay. Now, in this case, not everything. Let's talk about what would change. Domain. Did we do anything really to change that domain of our real numbers? No, we haven't changed the domain. Any exponential function, domain is always all real numbers. Okay, always. I don't care what has been done to it, it's always all real numbers. Okay, the range. Okay, did we shift anything up or down? Did we move up or down at all? No, we stretched it, but we didn't actually shift it. So we haven't changed the range. We haven't changed our end behavior. Okay, if we look at the graph, it's still behaving the same way. We go to the left, our y values are still going way, way up. If we go to the right, the y values are still leveling off at 0. The y-intercept did change. Go to your table. At 0, the y value is now 8. So the y-intercept did change. But really, that's the only thing that we've been identifying that has changed for this one. Okay, everything else would remain the same because we didn't do any up or down shifting. That's really what changes things for this one. Okay. All right. Oops. Okay, let's look at 3 and 4. Okay, let's look at 3 and 4. They've got a little bit more going on with these functions. So the parent function for number 3 is 4/3 to the x. It's just the base and the exponent. Okay, so we've got several things going on this one. We've got a minus in front. We've got a +2 in the exponent, and we've got a +7 on the end. So let me label them with their letters so that you can look at your notes at the top. So that negative in front is like an A. The +2 in the exponent is H. The +7 on the end is K. So if A is negative, it reflects over the x-axis. So it reflects over the x-axis. It's just -1, so it doesn't stretch or shrink. It's just reflecting. The +2 is an H, so that is a horizontal shift to the left because it's the opposite of what we expect, so left 2 units. And the +7 is a vertical shift vertical is what we expect, so +7 is going to go up 7 units. Okay, let's look at number 4. Number 4 has the same stuff going on. We've got this coefficient in front, that's an A. We've got this number right here, that's an H. And the -2 is a K, so our parent function is 5 to the x. Okay, let's describe our transformations. A is not negative, so it doesn't reflect, but it is less than 1, so that is a vertical shrink. By a factor of 1/2. H is negative, so that's a horizontal shift right 4 units. And the -2 on the end is a vertical shift down 2 units. Okay, let's talk about some stuff that we've got to remember when we're asked to graph. Because the calculator, I had no problem. I want you to use the calculator to graph these. Okay, I want you to use the calculator to graph these, but just like with rationals, you've got to know where to put the parentheses. Okay, you got to be careful with your parentheses. So let's look at number 5. The directions say graph each function and identify the key characteristics. So if we're going to graph this, we need parentheses around the x plus 5. I encourage you, when you get a problem like this on your paper, go ahead and put parentheses around the x plus 5. When there's more than one number in the exponent, if there's more than just x in the exponent, you got to have parentheses around it. So 2 raised to the parentheses x plus 5. Now, before we actually graph it, who can tell me what that transformation is going to do? Is it horizontal or vertical? With the x is horizontal. Okay, is horizontal what we expect or the opposite? The opposite. So it's going to go left 5 units. Okay, so 2 to the x, it used to go through 0, 1. It ain't going through 0, 1 anymore. It's way over there on the left side of our graph. So let's go to the table to get some specific points here. -3, 4. -2, 8. -1, 16 is off the charts, so I'm going to go a little bit further left. -4, 2. -5, 1. That should make sense if we were originally at 0, 1, and adding 5 to the x shifted us left 5, so it should make sense that that is -5, 1. And then -6.5, that's pretty sufficient to be able to fill in the rest of our graph here. Okay, let's talk about these key characteristics. The domain. It does not matter what we do to an exponential function, the domain is going to remain all real numbers. Always, 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 always. Okay, the range. Has it changed? Nope. Our y values are still positive. They're still greater than 0. We didn't move up and down or anything, so that doesn't change. All right, as our x values go over here to the right. Now, I know we're nowhere close to it with what we have graphed here, but look at the right side of this function. Where are the y values going? Up, so they're going to positive infinity. The left side, they're going to 0. Okay, our y-intercept, we can't see it, but we can go to our table and we can find it, right? Where x is 0, what's our y value? 32. That's a big one. Okay, and our asymptote, we didn't change it. Okay, we didn't move up or down, so our asymptote does not change. All right. Okay, just a couple more that I'm going to do with you, and then I'm going to turn y'all loose. Okay, so number 6, if we're graphing this in the calculator, we do not need any additional parentheses because x is by itself in the exponent, so we just need the parentheses around the 1/3. That -2 does not need to be in parentheses because it's not in the exponent. So it is fine just the way it is right there, like I put it on my calculator. Okay? That -2 does not need to be in parentheses because it is not in the exponent. All right. Before we hit graph, is it exponential growth or decay? Decay, because the base is less than 1. We didn't talk about that on number 5, but that's okay. What does that -2 do? What does that -2 do? Vertical shift down 2 units. I know this wasn't part of the instructions, but Still trying to get this in your head. Okay? So now let's subtract. Okay, there's the decay we're expecting. Yes, sir. Press zoom 6. Let's see if that fixes it. Did it work? Okay. All right. So there's the decay we're expecting. We said that was a vertical shift down 2 units. So finally, our graph has crossed the x-axis. I told you it would happen eventually. It just hadn't happened yet. Let's go to the table to get us some values here. Let's see here. -2.7 is the first one that will fit. And -1.1. 0, -1, that's a little different. Let's go ahead and fill in our y-intercept now. Since we went ahead and plotted it, go ahead and list it. -1, -1.67. Okay, and what do our y values seem like they're getting closer and closer and closer to here? -2. Okay, -2. It has been 0 so far. I switched it up on you. Okay, so we still have not done anything to change that domain. Still all real numbers. Does not change. Now, our range. Has that changed? Our y values? Yeah. All of our other graphs have been above the x-axis. Is this entire graph above the x-axis? No. It's above a certain value. It's above -2. Okay, this range is y is greater than -2. So let's talk about end behavior. As our x values are going to positive infinity, our y values are getting closer and closer to that -2. On the left side, as our x values are going to negative infinity, the y values are still going up, still going to positive infinity. And have you noticed that the range and the asymptote are always the same y value? For the longest time, it was always 0, but now we've shifted it down, so now it's -2. Okay? So look at number 7. We've got 2 things happening to number 7. Our parent function is 3 to the x. So is that exponential growth or decay? Growth. All right. So the 1/2 is a shrink, a vertical shrink by a factor of 1/2. And the +1 is a vertical shift up 1. Okay. The only thing that we need to worry about parentheses with here is that 1/2 in front. We do need to put parentheses around the 1/2 times 3 to the x. We don't need any parentheses there because x is the only thing in the exponent. The +1 is fine where it is. Okay, let's look at the graph. Okay, so it should be kind of clear that we went up 1 unit because our line doesn't disappear anymore. Our graph doesn't disappear. We can see it a little bit more clearly. Let's look at the table so we can plot some points. Ooh, big numbers. I need to move over. Okay, 2, 5.5. 3, 4, 5.5. 1, 2.5. 0, 1.5. -1, 1.1. What are our y values getting closer and closer and closer to 1? Okay, so they're leveling off at 1 here. Your line needs to, or your graph needs to get really, really, really close to 1. Okay, domain, still, all real numbers. Always, 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 always. Our range, what are our y values greater than? Do we have any y values down here below the x-axis?
No.
No? Do we have any y values right here? Nope, not right here. Where do they start? At 1. At 1. Okay, as our x values are going to positive infinity, the y values are going up. The left side, as our x values are going to negative infinity, the y values are getting close to 1. That number with the range is always going to be one of your end behaviors, and it's always going to be your asymptote. Let's go ahead and fill that part in. Y equals 1 down there for the asymptote. The y-intercept was 1.5. 0, 1.5.